Hello and welcome, future sonographers. Today we're jumping right into chapter 2 of Edelman's book, and we're going to talk about the characteristics of sound waves. So we're going to describe what is sound. First off, we need to understand that sound waves transfer energy through a medium. Okay, now how do we get our energy? We get it from the sound beam. Okay, that comes through our transducer, sending sound. Now, what is a medium? The medium is human anatomy. We need a medium in order for sound to travel. Sound can't travel where there is no matter, like in a vacuum. It needs to have something to travel with. Now, the first characteristic we're going to talk about is that sound is mechanical. What that means is that energy from the sound beam is able to travel through tissue via something called particle motion. Now, I know that sounds really complicated, but all it really means is that all human tissue is made up of these little particles, okay? They can also be called molecules. They're just very small building blocks of a human. And here's an example right here, two very small building blocks of a human. As our sound beam, we have our transducer here and our sound beam. As our sound beam sends sound into the body, that sound is going to excite those particles. Those particles are going to start to vibrate, okay? And this vibration is going to excite the next particle over. So on and so forth, all the way through the tissue. It's going to be excite, bump into, excite, bump into the next, all the way through the tissue. This is particle motion. Now, some tissue in the body has a lot of particles in it. Okay, this is going to be very dense tissue. And some tissue in the body has not a lot of particles within it. This is very not dense tissue. This changes how our sound wave is going to be. As the sound enters into the body, the areas that have really dense tissue are going to cause the sound wave to form a peak. Okay, that's that up like a hill. So a lot of particles, a peak in our sound wave. Not a lot of particles within the tissue, not very dense tissue at all. It's going to cause our sound wave to form what's called a trough, T-R-O-U-G-H, okay? And this continues as we scan. The different tissues throughout the body are going to cause the sound waves to move accordingly. And the crazy thing is this all happens within microseconds. You can think of it like the wave at a sports game. The energy starts with one person, transfers to the next, and then the next, all the way down until it's complete. Just like this. Now, this brings me to my next point here. Sound isn't just mechanical. Sound is also longitudinal. And this is the second characteristic and last characteristic that we're going to be talking about today. Sound being longitudinal. And this is so easy. What this means is that the particles will all move in one direction, in a longitudinal direction away from the sound source. And our sound source is always our transducer. Sound will move accordingly. I hope you enjoyed this presentation on the sound wave characteristics. Next class, we will be jumping into the sound wave parameters. See you next time.